Alright, welcome back, generals, to another Let's Fix the Generals 0 Hour to make the best game ever. Okay, so we have, last video, we have made some progress, yeah. I think we need to clean up what we have and submit it, yeah. Okay. Okay, so we got rid of this enum class, that's good, of this alias of a function and this array, okay. Imguip, this is simplified, great. Here also got rid of a whole lot of junk, yeah. And here as well, fantastic. And here, active function indices, okay. Remove this function, yeah. And simplify this function, set up pandas, okay. Then edit the flags here, build all named function indices, build all named function indices, yeah, okay. Set external filter condition, set external, yeah, if not this or not that, yeah, this looks correct. Function indices, yeah. Is matched, yeah. If is matched and not, show match functions, return false. If not is matched and not this, return false, okay. And then we remove this garbage here, okay. Good, a functional, yeah. Then we edit this member and that, okay. Then we edit this filter callback. Filter callback. Yeah, container. Filter has external filter condition. Has external filter condition, yeah. Yeah. Filter callback. Yeah. Filter callback. Filter callback. Yeah, I guess it's fine. Good, then we added flags here, there, to various functions. A lot of functions. And run our options, builds, bundles, flags, builds. How about we rename that to build bundle flag, builds, bundle. Build bundle flags. Build bundle flags all. Compile. Okay, so we got this guy and we set the flags to all, yeah. That is fair. And then we pass the flags here. Here I think think we can omit this first part here. Just pass this thing. Flags. Flags here and there and there and then there. Pass it everywhere. Okay, here we added the conditions, build matched function indices. Flags, build, matched function indices, matched function indices, yeah. Matched named function indices. Matched named function, okay. Unmatched named function indices. Unmatched, yeah. All named function, all named, okay. This looks correct. Yeah. Seems correct. Okay. Good. And then here we have name function. Flags, flags, flags. And the same bullshit here. Oof. Shrink to fit. Reserve. Yeah, flags, reserve. Function. Yeah, it's probably alright. Good. Okay, this looks pretty good. Let's have one more go at the UI to see if it actually is all correct. Let's click some buttons. Yeah. So let's start with a single bundle. Yeah. So, this looks good. Now let's also do a filter ASCII. Let's change the bundle. I think this is pretty good. Yeah. Yeah. I don't see a fault here. Seems to be fine. Okay, cool. Yeah, then I think we can submit that. Lots of deletions, that's good. But also some additions. All right, so basically, what did we do? Simplify functions. Simplify functions. Simplify functions data per file. Simplify functions data per file. Simplify functions data. Simplify functions data to a single instance per file. Functions data to a single instance per file. Yeah, let's describe it like this. I think that is fine. Okay, great. Great. That is submitted. It works. Fantastic. Good. Did we forget anything though? Let me see once more here. Don't think so. No, probably should be fine. Good. Very good. How does the data look, by the way? Oof. Could move these booleans up here. Maybe. Not important. Okay, let's see. Next step is we probably need to start thinking about loading the we need to think about next steps for disassembling functions and loading source files and so on. Let's see. So, okay. Selection changed. Yeah. Okay, so here we need to call a on functions interaction here and here as well. Can already add that. Void on functions interaction. Okay, and there we call this do something file dot on functions interaction. Same here. Okay, and what do we do? I think we first need to check. We need to check if it's necessary to do something, right? Because maybe the selected function has already everything loaded for it and it's ready to go, right? But if not, then we need to start loading things. Yeah. We probably need so we do have functions for async, compare async. Load and compare async. So we probably need a new function. We also need to make sure that if we disassemble a function, that there that while basically there cannot be any duplicates. There cannot be any duplicates. Also we cannot process some function and then the problem is if we make a box selection, like we add one function after another. Poof. Poof, poof. How do we do this? Let me see. We could use this structure here to store some additional data. No, I don't think so. Has loaded source file. I think when we select a file, a function in the UI, then we want to mark it as we have begun processing this function. We save this information so that there's no one, so that if we reselect it or click on it again or whatever, it does not reprocess it at the same time. So not sure. That is that's an interesting question. How we do assemble the data to process the functions. If we click on a single function, it essentially would just process a single function right as we click. But what do we do if we use selection box? I don't know. The problem is we would have to assemble some sort of intermediate list of the things that we have selected. If it was a contiguous block that we selected, then we can use a span to describe that block. But if it's a block with holes, then we can't do that. Yeah, that's a bit of a problem. And I don't know, issuing async commands for every single thing, every single function, that sounds very expensive. We shouldn't do that. Okay, how do we bundle our selected functions? There must be some clever way. Let's think. Some clever way. There probably is a clever way. Well, what we can do is, when we have a selection, I think I have an idea. When we make, when we get any selection change on, when we call into on functions interaction, then we go through all the active functions, all the filtered functions, and we check from start to finish which ones we can process. And if there are adjacent things that we can process, then we bundle them into a span. And if they are single, then they just will be a single item in the span. Yeah. Yeah. I think this is how we can do it. And this is how we like avoid making super small chunks for everything. Yeah, I think this will work. Yeah, and basically the async commands will be issued as soon as we select something. Yeah. Okay, this should work. Yeah. And if we select everything, then everything goes into a series of big async commands that have like a huge list. So if we, for example, press Control A to select all in the functions list, then it should assemble like the span from start to end, essentially. Yeah. Okay, I think this sounds like a good approach. Okay, and then we would need a function. We would need a function, something like void good question. How do we call this? Okay. I'm not too worried if we don't get far in this session with this. I think as long as we lay out the planning and the fun, where we need to go, we'll be happy already. Okay. So let's not stress ourselves. Yeah. I'm struggling with naming again, as always. Okay. Well, what do we want to do? We want to kick off disassembling the function. Maybe call it maybe we call it process or load function. Load function sounds weird. maybe analyze functions, analyze functions async. Yeah, maybe analyze functions async. Yeah, maybe. Yeah. And then analyze functions. Now the question is, what do we pass? Oof. I think we need to pass the program file revision. Poof. 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 Program file revision. Oh boy. Yeah. Analyze functions, program file revision descriptor. Yeah, but then we also need to pass span const index t function indices. Right. Yeah. Do we need to pass anything else? Or would that be enough? Might be enough. Yeah, we would just need to guarantee from the user side who calls this async function that there's no overlaps with function indices from one call to another. Yeah. Yeah. And let's see if we have all the data in there. So it would work with these things here. And with the named functions and with the storage. Yeah, I think everything is in here to do that. Let's think about it. We don't need this. No. Revision. No. Selected bundles. No. No, I think this would work. Yeah, I think this interface is perfectly fine. Yeah. Until, of course, it's not, which is possible. Okay, so im GUI app. Ta-da. Okay. Okay. Then. Yeah. Analyze functions async. Yeah. Named functions. Hold on. There's a problem. There's a problem. This would not work for all the runner commands that want to build comparison here. Where do we have this? On our options. Here, comparison records. Comparison. So this requires match functions. Yeah. For bundled functions, for selected functions, matched functions indices. I see. So we need two functions. Const named functions pair. Yeah, I think we need some more here. Where do I click there? Here. Analyze functions async, and we need analyze comparison. Well, analyze. The naming is a bit shit right now, but maybe we get there. Maybe we get there. So this one will need also a span. Yeah. Span. Okay, so here also we put a span const index t matched function indices, and this is named function indices. Yeah. Okay. I'm not so happy with the function names. Poof. Let's see. Load and compare. I think the problem is here we have a compare async and then we have another compare async. It makes it a bit confusing. Maybe we should rename this to like initial compare or start compare async. how do we call this? Load and compare. Compare async. Shit. How do we call this? Maybe we call it analyze matches async. Yeah. And then we need another function that encapsulates both, I think. No? Ah, boy. Oof. Oof. Analyze functions async. Analyze matches async. Yeah. Maybe we call this init comparison async. Load and init comparison async. Maybe that would be fair. Because compare is ambiguous. Like it sounds like you do a compare, but what does it actually do? If we say init for initialize, maybe that makes it a bit clearer that we just initialize something, but it's not the real deal yet. Init comparison load and init comparison async. Yeah, maybe that's better. Then here we do analyze functions async. And then you have a analyze functions and matches async. But then the question is, how do we go from one to another? Oof. Functions, matches. Ah. I guess we'll figure it out when we get to implement it. Okay, there we would basically need to pass. Oof. Shit. Name function indices. Well. can maybe make this guy does cover everything that this would do as well. I think we can do it from this angle. Yeah. So we call this guy here for the unmatched functions, and this one we call for the matched functions. And everything that this does for the unmatched function, this one already also does for the matched ones, to make sure that the functions are disassembled and so on for the matching. Analyze. Analyze matches. Yeah. Okay, yeah, we have to see. Yeah, we have to see. Well, well, I don't know. It's okay. I think things will become clearer once we start implementing this stuff. But for now, this looks to me like this could be the interface. Poof, it's really hard to say. It's really hard to say. Okay. Then, okay, and let's think about what we do here in on functions interaction. Oh. I think that's not quite the right place, isn't it? Shit. Yeah, this is not the right place to to do this, because we also need to work on comparison descriptor eventually, yeah. On functions interaction. Okay. How about we put this here. On functions interaction, and we pass the comparison descriptor. Okay. Then we remove this. And we call this. And we pass on selection changed. On functions interaction, we pass a descriptor. And we should probably also pass the file. Yeah, pass a file. Descriptor and file. Okay. So we have this guy. And now the question is, should it be const? Shit. Comparison descriptor. Fire. just call it descriptor and file. Maybe we can also rename this here. Ads. Add program comparison. Maybe call this, oops, update closed program comparisons. Okay, on functions interaction, descriptor and file. Yeah. And then in here, so basically we go through all functions and we just assemble spans and send out commands. Yeah. And then the async commands, they check what work is necessary. Yeah. Okay. But how do we keep track of what is being worked on? It would have to do that somewhere in here. I guess. Poof. Maybe. Poof. Oh man. Okay. Yeah. Okay, so we have a file on functions interaction file. Okay, let's do for file dot function indices filtered here. Let's do auto filtered const. Okay, filtered. Actually, do we have a function for this that helps us? No. Well, wait. Get filtered bundle, get filtered named function, get active function indices. Get active function. Filtered. Okay, let's get back here. So we have filtered function, and we say for index t, index is named function index, edx, index, filtered so named function index. Oof. No, that's not the right way. No. We need to create a size ti equals 0. Let's do const size t filtered count equals filtered dot size I smaller filtered count plus plus I. Okay. And then we start with filtered I. So let's create a size t first index 0, size t last index 0. Yeah. First index, last index. Filtered count. Let's just call it begin, end. So we say filtered do we have a helper function here? Get filtered name function index. Get filtered name function filtered index. Int filtered count int I file dot get filtered named function I, and this returns named function named function named function. Good. That's const. Okay, and now we check begin and 0 0. So if if named function no, we don't check it like this. We need to I think maybe we just pass. Wait. I think we just pass on the filtered as is, as a span, right? Yeah. Yeah. I think what we do is span const index t named function indices, and then we just give it the filtered list. That somehow doesn't work. Filter type. Dot data. Begin and okay. No, that's wrong as well, because yeah, that's wrong. This will be hard. We need to save a state. Oh, how do we implement this? Okay, this is hard. Oh my gosh. I thought I was on track, but now thinking about it again, I'm not. Ah, boy. By the way, this updates. Maybe here we should also say and not p has active command. Okay, we need to somehow, we need to say, we have a range. The problem is if we change the filter while the async command is processing, then this would be illegal here, this. Oh boy. Yeah. This open window. Oh boy. How do we do this? We could have a set where we save the function IDs that we have already processed. God damn it. Index. Oh boy. The function. Oh my gosh. This is hard. Oh boy. So we need to, I don't even know how to describe it. Oh man. We need to say... I can't concentrate right now. I can't concentrate. The concept slips through my mind. Okay. Think. Think. We need to find... So we have a vector of indices, but it's unstable. The vector is unstable. Because it can change when we type the filter. Span. Ah. Vectors. Oof. Oof. We could have a separate vector where we just push all the function indices in that we process, that we analyze, that have async commands running, and it just stays there. And then we know which functions we have already processed. But the problem with this is to look up in this vector would be very expensive. We could reserve the size according to the max functions that there can be. Yeah. So it would be relatively stable. We can use spans on this guy. Yeah. Yeah, but the lookup will be expensive if we then check like, okay, fuck. Oh, this is not good. Well, we could have we could have two. We can have two vectors. One vector where we push back the new indices to process, and another where we save the state whether or not a function has been processed, and then we have fast lookup. Yeah. 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 Would require a bit of memory, but Sure, why not? So basically we would have a std vector index t. We say analyzed function indices. Let's make a comment. Named function indices that have been sent to async commands. Named function indices that function indices that have been assembled from multiple bundles, or by named function indices that have been assembled from maybe we call this async function indices. Well, or processed. Processed. Yeah. Named function indices that have been sent to async commands. Yeah. And then we need another std vector. Bool. Index to processed function. Well, how do we name this? Oh, again, I have no clue how to name this stuff. Basically, we will have a function. Bool has or is function processed, or is function analyzed? Analyzed function indices. Has function analyzed function states. Array vector of booleans for all named functions that indicates whether a function has been analyzed. Vector of booleans for all named functions that indicates whether a function has been analyzed. Oh, it's written with a Z. Okay. Analyzed. So is function analyzed? Is function is named function analyzed const get filtered named function, and here we pass a index t named function index, and here we pass a just index named function index. Is named function analyzed? Is named function analyzed? Okay. And so this one would basically simply return analyze function states, name function index, done. Okay, that is simply enough. Now the next thing is we need to initialize these two guys. The question is where? Bundles ready. On bundles changed. Oof. Well, for starters, prepare rebuilds. Here we can free these guys. But we need to somewhere initialize. But where? Basically, when the named functions are ready. I think we can do it in let me see. Create new revision descriptor. Create load commands. Chain to last. Init comparison async. Let me see. If not named functions, build named functions. Yeah. Build named functions. Build named functions. Ah. Create build name function. Poof. We need to couple it somehow with build name functions. Or if it's already built, then set it. Poof. Shit. Init comparison. Init comparison. How about go to next async task? auto delayed commands, change commands. Chains callback. Bundles ready. So we say here command chain to last, chain callback. And we add this to our commands. And we say if bundles ready, so basically it will now enter here. When everything is done, it always enters here. Everything is loaded. And then here we can say can say void init init and we say so revision descriptor, well, assert revision descriptor is not null, and revision descriptor named functions builds and revision descriptor name named functions, yeah, dot size, say size t named function count that const. Okay, and then we say analyzed function indices dot reserve name function counts, yeah, and analyzed function states we put std fill n No, let's do function states dot resize name function count false. There we go. Okay, this should do it. Yeah, let's put a breakpoint in here. Yeah. Okay, so the idea is that once everything is built, we call into this init function here. Maybe we add a comment here. Init function is called when all async commands init function is called when all async commands have finished. Async commands towards initializing what? Towards preparing. No, towards all async commands for the rebuilds have finished. The init function is called when all async commands for the rebuild have finished. Yeah. Let's add a comment here as well. Must be called, well, not necessary to document. Good. I think this makes sense. And so that means we have now some objects to work with, these guys. Yeah. Yeah. Okay, let's comment out this junk here. It's not called. Oof, okay. So we've made some mistake somewhere. Did we actually call init or not? Init comparison. Here, everything is loaded. Initialize. Initialize. So how about we add a void init here? Let's remove the comment from here. Init. Init. Okay. And init. Okay. And then we probably also need to init something for this matched functions thingy, but yeah, don't need that right now. Matched functions build. Good. Let's try again. Compare. And it's still not called. Because we still have it not hooked up correctly. I need a break. Yeah. Comparison descriptor init. There we go. Now we're good. Compare. Okay, there we go. So name function count is 345. So we reserve this guy, and it should never go above that, obviously. And we also resize this, and it's all false. Great. Okay, this should give us all we need to work with this. Yeah, here we have a lot more indices. Oh, but I see another problem. What if we have multiple comparison windows open and they try? Oof. Yeah, this is not proper. This is not proper, no. This stuff here needs to be part of revision descriptor. Yeah. 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 Oh, god damn it. Yeah. To do move to, well, let's do it now. Oh boy. Yeah. So name functions. Let's move it here. Name function indices that have been sent to async commands. There we go. Yeah. So basically when this guy is set here, build name functions, then we set this as well. So we take this guy, name functions count, and then revision descriptor, this, there we go. Maybe we put this up here. Size. Name function count, reserve, resize. Yeah, okay, so it has to be here. And that means we can let's for now let's just make it empty. And we don't free this container ever. We don't free it ever. Yeah. Yeah. And then is named function analyzed. So this here, let's do a named function analyzed. Index named functions built index okay. Okay, I think this is where it belongs. Yep. Okay. Okay. Yeah. And now we can work with it, I think. Okay, we're getting there. It is a process. We need to figure out how we do this. Obviously, we want to implement the things fast. That's the key. Like, we always have to think about how do we want to do things fast. There's always a way to do it quick and dirty and bullshit way, but that's not the right way. That's why it's always worthwhile to take a moment and think a while about the design. The flow of data. That's all that matters, the flow of data. You want the data to be fast. That's it. And I think with this in place, we should be able to build it fast. So whenever we have a new selection of functions, we check if it has already been analyzed. If not, then we push it here into this vector, whatever has not been analyzed. Push it in there. And then from the begin of where we pushed to the end of where we pushed, the amount of elements we pushed, we take this range and we issue the async command with this range that we have pushed into this container. And then it can work on this. And since this vector is not supposed to reallocate ever, and it's not supposed to change. We don't erase anything. We don't reallocate. So it will stay there in memory, and the async command can work as long as it needs on this thing. And then when it's done, then it just stays here like this. We don't clear it or anything, it just stays. And this as well. And this is how we know that we need to do something or we have done something already. Here. I think this works. Should we have another helper function here maybe? Name function analyzed. I don't think so. No, we just work directly with this vector here. It should be fine. Okay, cool. Does it compile? Yes. Okay. But I think we have a plan now, the rough plan. And I think it will be efficient. Yeah, I think so. It will be efficient. It will be robust. It should be easy to maintain. Yeah. Yeah. I like it. I like it. It sounds like a good plan. Okay. And I suspect that we need something similar than here for the match functions. For this one here. Yeah. We probably need the same thing here. Like, has this match function already been built? So we probably need this thing here. Let's make a copy. Here. Matched function indices that have been sent to async commands. Vector booleans for all matched functions that indicate whether a function has been A match has been analyzed. Analyzed matched function indices. Analyzed matched function states. Then we create here a matched function analyzed. Bundles ready. MGUI app. Return. No. Analyzed matched function states. Index. There we go. Matched function indices. And basically we also initialize these guys when this one here is set, which is set here, which somehow it doesn't want to jump to here. Let's make a copy of this. Res matched functions here. Named match functions. Okay. So I suspect that here we put this, that, this, and matched function count, and then matched here, move this, matched, and there we go, analyzed, matched, okay. Okay, and then I don't think we even need the init anymore, but okay, let's leave it there for now. Yeah, maybe we don't need the init. To do remove. Yeah, matched function count. Okay, yeah, I think this will work. Maybe we should put it here into a scope. Okay. Matched function analyze. Yeah. To do remove. Okay. Okay, good. We have a plan. We didn't get all that much done, but it's okay. I was mostly thinking about strategy. Yeah. Mostly thinking strategy. Good. Yeah, then I will quit it here. Yeah, it has been 2 hours, almost nothing done. Good. Well, sometimes it is like that. All right. Good. Then next session we continue right there. Try to get all the steps in place to kick off analyzing the functions, the selected functions, one after another in a highly efficient way. I think it's possible. Yeah. All right. Sounds good. then yeah, I wish you a great day or night. Until next time. Goodbye.